This is Pravash. Welcome to Math and More. Quick recap of the previous video. We discussed the probability of getting at least one 6 when we roll 3 dice. We got the answer 91 by 216, which was 42.13%. We established it experimentally as well using the RAND function in Excel. So, by the way, RAND generates pseudo random numbers between 0 and 1. Why pseudo random, not pure random? Well, that's a topic for another day. Right? Today, we'll expand the problem and try to answer the question how many dice rolls guarantees at least one 6? We intuitively know that rolling more and more dice would increase the probability of getting at least one 6. However, it would never be 100%. It is theoretically possible that we roll a million dice and not a single one lands a 6. The probability of getting at least one 6 is exponentially high, maybe 99.9999999% for a million dice rolls, but it's still not 100%, right? So let's look at the formula we have used. So here, if you remember in the first video, we discussed if we roll 3 dice, what's the chance or probability that we'll get one 6? And the formula we found out was 1 minus 5 by 6 into 5 by 6 or into 5 by 6. That is 5 by 6 raised to the power 3, right? So this gives us 42.13%, right? So if we generalize this formula, so what's the probability we get at least one 6 with n dice? It would be 1 minus 5 by 6 raised to the power n, right? So what I've done here is, in this table, I put the number of dice here on column A. Column B represents the percentage using this formula, right? And we have drawn this graph. So this graph says as we increase the number of dice, the probability of getting one 6 increases, and it increases exponentially. You can see with 10 dice, there is 83.85% chance that at least one will land a 6. Similarly, with 50 dice, it is 99.98%, right? And it increases exponentially, and never reaches 100%. It tends to 100% at infinity, right? So the answer would be infinity actually, but we get the gist, right? So it requires those many dice, or an infinitely large number of dice to guarantee a 6, right? So there is an auxiliary question also we're trying to answer. The auxiliary question is, what's the probability that all of them will land a 6? So we can understand this probability will decay really fast. With one die, it will be 1/6, which is 16.66%, which is understandable. With two dice, it will be 1 by 6 into 1 by 6, right? Similarly, for 8, it's 1 by 6 raised to the power 8. So this decays really, really fast, gets to 0. It's actually not a 0. It's really extremely small, right? The decays to 0 really fast, and it's extremely small. So as you can see at 50, we have this number, right? So that means it's 1 in gazillion, right? So it's almost impossible. It's almost impossible to get all the sixes when you have 50 tries, right? This happens 1 in gazillion times. So let's see, what I've also done is trying to experimentally see if this 8, will try to roll 10 dice using the RAND function. We'll go to the next tab. So what I've done here is I have 10 dice here, and using the RAND function, you can say RAND, and it's multiplied by a 6, and it's rounded up to the nearest integer. So this gives me a number randomly between 1 to 6, and I've used this formula for 10,000 rows and 10 columns. So that means there are 100,000 cells here, 100,000 cells you can see, that uses this function to generate random number. So what am I doing here? I'm trying to see using a nested if. You can see here, nested if. I'm trying to see if there is a 6, at least one 6, then give me a yes. You can see it's almost all the yeses here. I don't see any no. You can scroll down. Here is a no, right? Here is a no. You can see the values, right? 444, 55. So there is no 6 there. We can keep on refreshing, right? If you hit F2 enter, F2 enter, it refreshes. You can see the first is a no now. So anyway, so what we're doing here is, with 10 dice, roll 10,000 times. We are inspecting how many of those rows has at least one 6. So the answer is 83 8380, right? So which is 83.8%, which is pretty close to the calculation we have done, right? So let's refresh how the number changes. Let's see. So it's about 83%, and it's very close, by the calculation I've done in probability. And then the second question, the auxiliary question is, uh, you know, what's the probability that all of them is six? This is really really difficult because you have 10 dice here, and you are trying to get 10 sixes, right? So that it should add up to 60. I don't see a single one here. Out of 10,000, not a single one. The probability is actually not zero. It is really small. It's 0.00000. It's really small. It's actually 1 or 2, 1.65 in 100 million, right? That's how small it is. It's it's so small that it's probably equivalent to a person getting hit by lightning 7 times. Thank you so much.